Hi there, here is our example 10 for conditional probability. So that's going to be the focus of this particular little wee video. Now you guys are getting thrown right into this, so using this as your example. So the book unpacks the ideas that you need to know by working through examples. So I'm going to do that here, but I haven't left you high and dry because I have some previous videos for you that go back through and explain some of the stuff. So I'm going to try and just bring it all together here anyways, using the book's approach together with a more explicit overview of probability ideas. So we've got a two-way table here. What it's showing us across the top is one particular event, so we can call it the vegetarian event. I would say that vegetarian and non-vegetarian are mutually exclusive, and I would say the probability of vegetarian plus the probability of non-vegetarian would equal 1. So they are also independent events. Here we have gender, so that's a second event. So this is the gender event. Now this two-way table is sometimes called a contingency table, and that is used to organize information about two-way events. Okay, so it covers everything about those two events together. They have given us out of 100. Now these are subtotals. So the vegetarian totals is the 18 and the 25 people. So there's 43 vegetarians, 18 males, 25 females. The non-vegetarians total 57. Those guys together total 100. And this 56 is the subtotal of the males, broken into vegetarian 18 and non-vegetarian 38, and then the females. So whether we plus these this way or this way, we come to the grand total of 100. Now that's there for convenience sake for you to see that this is also a percentage table, but it's also numbers because they're talking about 100 people here. So let's always read around the context. So it says one person here is selected at random from those surveyed. Identify the event and use a table to calculate the following. So part A, they want the probability that's a male and vegetarian. So when you see the little N like that, that's and, because it looks like an end. N, do not confuse it with U, which is an upside down version of that, which represents union. Okay, so there's an N inside and, so when you see it this way, it's and, this guy is union. So what they want is male and vego. So if we just look at the table, we can identify that cell. So we're going to male vegetarian, which is 18, and we can calculate that as 18 people out of 100. And with probabilities, we always like to report them in decimals. Fractions is okay, decimals is better. So we just divide that out, 18 divided by 100, 0.18. Part B here, they want the probability of M given V. Okay, so what that straight up and down line there means is given. So they want the probability that that random person is a male given that they're vegetarian. So they don't care about non-vegetarians. What they're actually saying here is, now I'm just going to rub out my table annotations so we can make room to annotate for some of these questions. So what B requires us to do is given vegetarian. So we don't care about the, we don't care about the non-vegos. We simply care about the vegetarian group. So we're interested in 43 people. So that becomes like our subtotal. Contrast that to any old random body, which that was our subtotal. We were doing it out of all the people, all the survey in A. But in B, it's given that they're vegetarian. So it's just out of the vegetarians. So that calculation there is 18 males, but it's out of the reduced subset of the 43 vegetarians. That's what given means. So I'm just going to divide that out on my phone here divided by 43. So that is 0.4186. Okay, question C. Now that particular approach to B is conditional, all right? Given is a condition, given something like a restriction. So the restriction is this vegetarian event here. Just going to rub that out now so we can attack the next question, which uses this little code here with a little dash. So probability vegetarian dash. Now that means not vegetarian, given that they're female. So not vegetarian to me means meat eating, or, now just be a little bit careful. Yeah, so they've used the code in their table, which is all good. So not vegetarian is this 57 here, given that they're female. So our reduced subset for question C is just the females, given that they're females is the 44, subset 44 people. So we're interested in this group of 44 chicks, and we're interested in the non-veggies. So it's 19 divided by 44. Which is 0.4318. Okay. 181, so that's okay to 4dp. I don't know about the one above. Now 4 decimal places is good because that is the equivalent there of 43.18%. Sometimes 43.2% would be sufficient. We're just giving it to 1/100th of a percent. So that's okay. That's not overkill. So 4 decimal places is common rounding to report that answer. Okay, let's look at the last one. Probability vegetarian. Too easy, eh? So let's just rub out the annotations again. That is just these guys out of all of these guys. So it's the 43 out of the 100, which is 0.43. Hey, can you guys go ahead and do the questions that follow from this worked example 10? So that would be questions 2 and 3. And then you could come back to question 4, 5 when I do the example shortly. So if you want to pause this, go for it and do the questions up to question